properties of an entity. With the help of this attribute, we are going to identify an entity, an attribute that composed of many other attributes. Then we call that as a composite attribute. Key is an attribute or a collection of attributes that uniquely identifies an entity among entity set. The type of a relationships are similar to each other. Then if it is a collection of that, then we can say that as a relationship set. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of chapter 2 in the unit 1 of B.Ca's third semester, subject called Database Management System. In short, it is Dbms. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So just before getting into our today's session, we'll just have a quick recap of our previous session. As you all know that we started with a chapter 2. In that we had a discussion regarding what are the ER model concepts we have. In this you got to know what you mean by ER model, that is entity relationship model. So we all got to know what is an entity, what is an attribute, and also we had a discussion regarding relation. So that comprises of rows as well as the columns. That is what we already learned. Along with that, we had a discussion regarding what do you mean by an entity. Any real world object, either animate or inanimated, will be considered an entity. And also we had a discussion regarding what is entity type. Then we also had a discussion with respect to entity set. At last I started with this attributes. So in our today's session, we're going to see what are the different types of an attribute we have. Along with that, I will be discussing what do you mean by a key attribute, and then we'll see what do you mean by domain of an attribute, and then at last we'll see what do you mean by relationship type, as we did for the entity type and entity set. Here also we have a relationship type as well as relationship set. That is what I will be discussing in my today's session. We'll get into it. First, already you know what is an attribute, as we discussed in the earlier class. So an attribute will going to specify the properties of an entity. With the help of this attribute, we are going to identify an entity. So that attributes are the properties which define the entity type, and we are going to use oval symbol in order to represent this attributes. Fine. And also we got to know what are the different types of attributes we have. Here we have a simple attribute, composite attribute, key attribute, single valued attribute, multi-valued attribute, and at last we have this derived attributes. We'll see each type of attribute one by one. We'll see the first one. As the name indicates, it's a simple attribute. Moreover, an attribute is going to be describe the characteristics or features of an entity. So when the value of that attribute is atomic in nature, that means the simple attributes are atomic value which cannot be divided further. If you take the example of a phone number, then that comprises of 10 numbers. If I am taking it together with a country code, then it will be 12 numbers. So at that time, whenever I am taking only 10 numbers, that can't be further dividable. But if I am taking that as a 12 numbers, I can divide it as a country code as well as mobile number. But if I take an example of 10 numbers, that can't be further dividable. So whenever we have that kind of value, then we can say that kind of attribute as a simple attribute. The values of a simple attributes are atomic in nature. Then we can't further divide that into any other classification. So here you can see whenever it comes to the student phone number, that is an atomic value of 10 digits. So at most it will going to have 10 digits. But if I am taking both the country code as well as a number, then it will be 12 digit. So here you can see that we have an entity that will going to be represented by a rectangle, and we specify all these attributes with respect to oval shape. ID, we have phone number, age, and name. So all these are the simple attribute. Next, what we have? Composite attributes. As the name indicates, composite, that comprises or made up of more than one simple attribute. Then we call that as a composite attribute. An attribute that composed of many other attributes, then we call that as a composite attribute. Then how do we represent this composite attribute? That will going to be represent with the help of ellipse, and that ellipse will going to be connected with another ellipse. Then that is what it is not going to have a single value. Then it will comprises of which can be further dividable. And here it is made up of more than one simple attribute. So what will be the example for this composite attribute? You can take a student complete name. So that may comprises of student first name, middle name as well as a last name. Then we can say that kind of value with respect to the attribute considered as what? Composite attribute. Here you can see that we have a name. Name is itself an attribute. That attribute is further divided into first name, middle name, last name. Then we can say this kind of attribute as composite attribute. Next what we have? Derived attribute. We are deriving a value of an attribute from the real existing attribute. So this derived attributes are virtual in nature, that is not really existed in the database. I am fetching the value of this derived attribute from the value or from the attribute which is really exist in a database. So you can take the example of what student age. How can I find out student age? By the help of date of birth. So can we find the date of birth by having a age? No. So that age is a derived attribute here. I am deriving a value of an age with the help of that date of birth. Then we call that kind of attribute as a derived attribute. And also you can find the kilometers or you can find the distance. So you can have a source and destination. With the help of that source and destination, we can find out the kilometers or its length. That is what derived attribute. An attribute that can be derived from other attribute is called derived attribute. Then how do we represent it? That too with the help of this dashed ellipse. So with the help of dashed ellipse, we are going to represent this derived attribute. So it's the kind of attribute that is derived attribute that do not exist in the physical database. As I told earlier, it is not present in the database, but their values are derived from other attribute which is present in the database. So with the help of other attribute which is present in a database, we are finding a value of this derived attribute. If you see the example here, student, that has a name, and if it is a name, again we can classify into what a composite attribute like first name, middle name as well as last name. Okay, in that way we can specify. And also we have a birth date or a date of birth here. With the help of this date of birth value, I can find out this age. So age is in what? Dashed ellipse. So then that is going to be represented as a dashed ellipse. Then we call that kind of attribute as derived attribute. Next what we have here? Single valued attribute. When an attribute will going to hold only one value, then we can call that as a single valued attribute that contains a single value. Can I take the example of phone number? No. Why? Because there could be a chances of having more than one phone number. But if you consider the Aadhaar number, then it will be only one. PAN card is only one and passport is only one. Then we can say that kind of attribute value as what? So, single valued attribute, that is social security number or SSN number. Then what about this multi-valued attribute? As I taken the example of phone number. So phone number can be more than one. Social media account can be more than one. Email can be more than one. Then we can say that kind of attribute which will going to have more than one value. Then we call that kind of attribute as what? Multi-valued attribute. Then how do we represent it? With the help of this double oval. We are going to use double oval in order to represent this multi-valued. You can take the example of phone number here. Fine, we have a phone number that is multi-valued, that is represented with like this double oval. Fine. Next, we'll see what do you mean by this key attribute. So, if you take the example of student, we have a student ID, student name, date of birth, age, and we can have a course as a attribute. By which attribute I can in the uniqueness of a student, that too by making use of student ID. There could be a chances of having a same name, same date of birth and also same course. But will ID will going to be same for everybody? No, right? Then we call that kind of attribute as a key attribute. This key attribute is used in order to find the uniqueness of a tuple or in order to find the uniqueness of a relation. So that key attributes of an entity type constraint on the entities of an entity type is the key or uniqueness constraints on the attribute. So whenever we have this key attribute, that will going to hold only the unique value. So it will not going to have any duplicate value or redundant value, so that we can improve the consistency of a database. So an entity type has an attribute whose value values are distinct for each individual entity in the entity set, then we call that kind of attribute as a key attribute. You all understood here? Whenever we have this attribute, those value or value of this key attribute will going to be distinct from one individual entity to another individual entity in an entity set. Then here key is an attribute or a collection of attribute that uniquely identifies an entity among entity set. When I wanted to find the uniqueness of an entity, then we are going to have this key attributes, and its values can also be used to identify each entity uniquely. How can I get to know this is student entity, this is employee entity or department entity? That too by with the help of this key attribute, we can find the uniqueness of an entity in an entity set. So you can take the example of name. How do we find out the name of a company, or how can we differentiate one company with another company? By their name. And if you consider the vehicle with a registration number and vehicle number, we are just going to find the vehicle entity type. So that is how whenever we are using any of the attribute uniquely in order to find the uniqueness of an entity amongst an entity set, then we call that kind of attribute as this key attribute. Fine. We'll see the next topic. So here also we have some more example. The roll number of a student makes him or her identifiable among student. Here also key attribute comprises, or it will going to have a uniqueness, and whenever we are using it, it will just going to have a distinct value from one entity to another entity. Then how do we represent this key attribute in a ER diagram? That too by making use of each entity has its name, which is underlined inside the oval. So we have a oval, within that I am just going to underline. So above this underline we have to specify a name of an attribute. So it constraint that prohibits any two entities from having a same value for the key attribute at the same time. I can't have same value for all the student ID. With the help of student ID only we are making a distinction between the students, so that the ID should be the distinct value, or it should include only distinct value. So here you can see that we have a student entity that comprises of different attribute called ID, phone number, age and name. So here ID is of what? Key attribute. Why? Because how can I get to know this is key attribute? Because the name of an attribute is underlined, okay, and I am not taking date of birth, that is why age is in the normal attribute itself. This is one of the example for this key attribute. So we have three types of keys here in order to find the uniqueness of an entity in the entity set: primary key, candidate key, and also we have a super key. Then why do we use and how do we use this primary key? So in order to find the uniqueness of a entity in the entity set, then we are going to have this primary key. So will be the door lock is same for everybody's house? No, right? Then we are calling that as a primary key. Primary key should not be null, as well as it should be unique. So that it is the first key which is used to identify one and only one instance of an entity uniquely. Whenever you wanted to find the uniqueness of a tuples in an entity, then we are going to use this primary key. So if you take the example of employee table, there we are going to have this employee ID. With the help of this employee ID, then we can find the uniqueness of each employee in that employee table. Fine. So we can even select license number. Why? Because license number is unique for each individual employee, and even passport number as a primary key. So the attribute which we can use in order to make it unique amongst all other entity, then we can say that as a primary key. Then what about this candidate key? So it is an attribute or set of attribute that can uniquely identify a tuple. So instead of only taking an employee ID, I will take passport number as well as the license number together. So I can call the collection of attribute or a set of attributes as a candidate key. Apart from having this primary key, I am just going to have some more attribute or a set of attribute which is finding the uniqueness of a tuple, or it is used to identify a tuple in a unique manner. So except for the primary key, the remaining attributes are considered as a candidate key, and somehow it is strong as this primary key itself. So if you take the example of employee table itself, so employee ID is a primary key. So the remaining columns or remaining attributes will be considered as what? Candidate key. Then what about this super key? Super key is an attribute set that can uniquely identify a tuple, and also it is a superset of a candidate key. So apart from the primary key, the remaining attributes will be considered as a candidate key. So in this super key, I am just going to make a group of 2 or 3 attribute and another group of 2 or 3 attribute as another one set. Then whenever we are combining it, then it will become a super key. Fine. So in the particular example like employee table, so we have a employee ID and employee name. The name of the 2 employees can be same, but their employee ID can't be same. So then this combination also be considered as a key, so that the super key is a superset of a candidate key. So we have a several, you just imagine I have 8 attributes in the employee table. Employee ID is one primary key and I am left out with 7. I will call all those 7 attributes as a candidate key. So instead of having 7 attributes, I will make a group of 3 and I will make a group of 4. Then that will be considered as super key 1, super key 2. That is what we are having in a super key. So here then instead of having like if I wanted to call that as a employee ID, along with the employee ID I will take the employee name. So then with respect to the employee ID, that will going to correspondence with the employee name. Then I can make that as a employee ID in the super key. Fine. Here we have a example. You just imagine we have employee ID, employee name, employee address, passport address, license number, and we have a SSN or a security number here. So that this employee ID is what? Primary key. I call this as a primary key, and all these different columns will be considered as what? Candidate key. Candidate key. Okay. And I will take this employee ID and employee name. Then I will make this as what? Super key 1. I will take the employee ID as well as I will take the passport address and license number. This will be another super key. So I will take employee ID as well as employee address and their SSN number, and I will call this as a super key 3. Okay. So employee ID, which we are using as a primary key, will be primary key, and it should not be null as well as it should be unique, and the remaining attributes or a columns will be considered as a candidate key. In the candidate key, I can have a combination of one or more attribute to make a super key. We'll see the next concept, that is regarding domain of an attribute, and also we call this as a value set. Already you know how the table look like, correct? So this, if I consider this as a table that comprises of columns, or we can say that as an attribute, and also we have a tuples or a rows. So domain of an attribute specify the set of values which can be held by this particular attribute or a column. Then we call that as a domain of an attribute. For example, if I say an employee ID needs to be varchar or variable character, and if I say this employee name should be only character, then it should not accept any numbers or other than any of the data type than this character should not be accepted as a value for this employee name. Then we call that as a domain of an attribute. So that here each simple attribute of an entity type is associated with value set or a domain of an values. Then what it means? So it specifies the set of values that may be assigned to that attribute for each individual entry. Whenever we have in a table that comprises of different attributes, then what are the set of values that may be assigned to a particular attribute for each individual entry, then we call that as a value sets or a domain of an attribute. So moreover, in this value set or a domain of an attribute, we are going to specify the data type. What kind of the data type it has to be, and also we can specify the range. If I say varchar or if I say string, at the time I am going to specify the size. If the size is 20, up to 20 character it is able to hold. So here value sets are typically specified by making use of basic data type that comprises of what? Integer, string, boolean, float, enumerated type. By having the restriction of this data type, we can have this domain of an attribute or a value sets. Next, what we have? The relationship between the entities. So you all know a real world element, whether it is animated or inanimated, then we call that as an entity. Then how can I say what is the relationship between one entity to another entity? That specifies an association between the different entities are called relationship. If it is participating in a relationship, then we say that there is a relationship exists between the different entities. So that relationship is an association between two entities or any number of entities. If I take an example of, consider we have a student entity. If I say student entity, that comprises of student ID, name, their age, date of birth, like that. And we can have one more entity called academic course, course name and course year and course credits. So all those are the attributes. Then how can we relate or how can we build a relationship between the student and academic course? So that is what we can say that as enrolled in. Student will going to enrolled in this academic course. That is what specifies the relationship between the different entities. And here next we'll see what do you mean by relationship type. You know what is an entity type. So now we'll see what do you mean by this relationship type. So relationship is when an attribute of one entity type refers to another entity type. You already know what is a relationship. So when the attribute of one entity referring the attribute of another entity, then we can say that there is a relationship exists among the different entities. So whenever an attribute of one entity type refers to an entity of a same type or a different type, then we can say that relationship exists between the two entities. Then what is this relation? How it will going to be represented? That is represented as a references as a relationship, not attributes. So we are referring that as a relationship between the entities. It's not the relationship between the attributes. And then in the ER diagram, the relationship types, the type of a relationship, what kind of relationship it is. In order to specify that, we are going to use this diamond shaped boxes. With the help of this, we are going to specify the relationship between the different entities. So connected by the lines to our entity types, which are all involving in a relationship. So that the name of a relation is written inside the diamond box. I should specify what kind of relationship it is holding, and all the entities are participating in a relationships are connected to that relation by a line. So here you can see the example. We have a two entity. One is student entity and another one is course entity. How this student is related to this course entity? By enrolled in. Students are enrolled to course. That is why we are having a relationship between student as well as the course. Next we'll see about the relationship set. Relationship type specify what kind of relationship we have with, between the different entity. Then what about this relationship set? It is a set of relationships of a similar type. So here the type of a relationships are similar to each other. Then if it is a collection of that, then we can say that as a relationship set. Then it is called as a relationship set. In this relationship set also we have a attribute. So we also have an attribute for the entity. Same way we also have an attribute for this relationship set. Instead of calling that as an attribute, here we call it as descriptive attribute. The attributes of a relationship set are called descriptive attribute. Fine. We'll see the next one. Here we have a example. We have a relationship here. So it consists of 3 students and it is what enrolled for, and we have a different 3 courses. So that S1 or a student 1 is enrolled in course 2. That is what the relationship. Student 1 is enrolled in course 2 and student 2 is enrolled in course 1. Student 2 is enrolled in course 2 and the student 3 is enrolled in course 3. This is what relationship set. It is a set of relationship of a similar type. So here student 1 is also enrolling, student 2 is also enrolling, student 3 is also enrolling. So that this is what relationship set. That is what we can see with this example. Fine. Next, we'll see what do you mean by roles and structural constraint. So here, if you take the example of here itself, then if you are in a college, then you are going to play a role of student. But when you go back to home, then you are going to play a role of daughter or a son, or you will be playing a role of a brother or sister, like that. Same way, here also we have a roles. So what is its participation in a relationship? What it is doing? Then we call that as a roles. So each entity type that participates in a relationship type that plays a particular role in the relationship, then we say that as a role. So what is its contribution to the relationship? That specifies the name of a role. So that the role name signifies the role that a participating entity from the entity type plays in each relationship instance. How it is participating in a relationship instance? What is its contribution? How it is building a relationship between a different entity? That what specifies this role name and helps to explain what relationship means. If it is enrolled for, then enrolled is what? Role. And if it is a student, student is an entity, that is a role. And if it is course, that specifies the course. So here you can see one of the example. Here we have a work for relationship. If you consider an employee and department, so employee works for department, so that works for relationship type, employee will going to play a role of employee or a worker. And if you consider the department will going to play a role of employer or department or higher authority. This is what specifies the roles. Then here, role names are not technically necessary in relationship types where all the participating entity types are distinct. So here, no need to bother about the role names. Why? Because entity types are distinct or different than one another, so that each participating entity type name can also be used as a role name. So entity type name is only specifying a role name. This all regarding roles. Then what about this degree of a relationship type? What do you mean by degree here? The number of different entity sets participating in a relationship set, then we call that as a degree of a relationship set. So, if we have a 5 entity set, then we say that the degree of a relationship set is 5. Why? Because I have a 5 different entity set which is participating in a relationship set. Then we say that as a degree of a relationship set. So, based on the number of entities set, how many entity sets are participating in a relationship set, based on that we are going to find this degree of a relationship. Fine. Then what are the different types of we have in it? It can be unary, binary, ternary and n-ary. We'll see the first type, that is unary relationship. As the name indicates, in the unary relationship, when there is only one entity set which is participating in a relationship, then we can say that as a unary relationship. You can say the example here. Each individual person will going to have only one passport. So this is what the participation. One person at a time can have only one passport. And one person can have only one UID or Aadhaar card number. This specifies the unary relationship. Then what about binary? When there are two entities set participating in a relation, then we can say that as that kind of relationship as a binary relationship. So when we are going to have a two entities set here, one is student entity and another one is course entity. What is the relationship between them? They are enrolled. They have a student has been enrolled for the particular course. Then we can say this as what? Binary relationship. Then what about ternary? More than 2 or a 3. So the ternary relationship is an association among the 3 entities. So here we are going to have a different 3 entities and there is a relationship between all the 3 entities. Then when we require this 3 or ternary relationship, when the binary relationships are not sufficient to accurately describe the semantics of the association. So when we feel the binary relationship is not enough to describe this relationship among the different entities, then we can go with this ternary relationship. So here you can see that we have a technician, they are using notebook, and we have a project, for that also user using notebook, and notebook entity is also have this user notebook. This is how the relationship we have between more than 2 entity set. Then what about this n-ary? More than 3 here. When there are n entity set participating in a relation, then we can say that kind of relationship as a n-ary relationship. These are regarding what? Degree of a relationship. I hope you all understood my today's session. In my coming session, we're going to see what do you mean by the structural constraint. In the structural constraint, we have a degree and cardinality ratio of a relationship. At last, we'll see what do you mean by an ER diagram along with the different shapes, along with the advantages and naming convention in my next class. Let me meet you there. Until that, keep learning, keep on growing. Thank you.